Hi everyone, I hope you're doing well. In this video today, we are going to be learning about divergent plate boundaries. Okay, so this week we are learning about plate tectonics and how Earth's surface, or Earth's crust, is made up of about 20 different plates, which are pieces of Earth's crust broken into different chunks. Okay, and we learned that those pieces, those plates, don't just stay in one place, but they move because the magma in Earth's mantle moves via convection currents, right? Hot magma rises, cool magma sinks. That causes convection currents, and that movement of the magma in turn moves the plates that are floating on top of the magma. So since the plates are moving, eventually two of the plates are going to hit each other. When two plates meet, the edges of two plates meet, we call it a plate boundary. Okay, and there are 3 different types of plate boundaries. In this video, we are learning about divergent plate boundaries. So 2 divergent boundaries is when two plates, okay, the boundary between two plates, the plates are moving away from each other. At a divergent plate boundary, the plates are moving away from each other. Notice in this picture we have 2 plates and we have our 2 arrows. The arrows are pointing in opposite directions. The plates are moving in opposite directions. The plates are moving away from each other. One way to remember this is to think of the word divide. If you divide in math, you're breaking up something into smaller pieces. The numbers are moving away from each other. In this case here, we have 1 plate and we're dividing it into 2 plates. It's breaking into 2 plates and the plates are moving away from each other. So we have divide, divergent. So if you look at this picture here, this shows us a divergent plate boundary. Remember, we have our magma underneath the Earth's crust moving in circular patterns. And what happens there is when that magma is moving, right? If I look here, this magma is moving in a circular pattern. And that is going to cause the plates on top of the magma to move in opposite directions. Okay, so when those 2 plates move in opposite directions, it creates a little hole in between the 2 plates. So what happens here? Well, new magma from below Earth's surface rises up to fill that hole, and that's where we get magma rising to Earth's surface, and it eventually cools and creates new ocean floor. Okay, I said ocean floor because we typically see ridges along the bottom of the ocean, although sometimes we can see it on a continent too. Okay, so remember the plates are moving away from each other. That allows some magma to come up and rise to the ocean floor, and you get magma coming up to the surface, cooling to create new rock. Okay, again, we see the magma. These 2 plates are moving in opposite directions. One is moving to the left, the other is moving to the right. That causes a gap to form. Magma rises up from under the ground. You can see here the magma coming to the surface, that red magma on the surface. Magma is able to come up to the surface and cool to create new ocean floor. Okay, so for our notes this week, we're going to create a nice little chart comparing the 3 different types of plate boundaries. Today we are only learning about divergent boundaries. So let's go ahead and fill in divergent on our first type of plate boundary if you haven't done so already. And in a divergent boundary, let's fill this in. the plates are moving away from each other. Okay, our plates are moving away from each other. And a divergent boundary creates two possible types of features. Okay, one is called a mid-ocean ridge. Okay, so we'll often see that word. I want you to underline the word ridge. That's what's important there. We could also get what's called, I'm going to number these. This is 1 and 2. We could also get what's called a rift valley. Okay, and here I'll underline the word rift because that's what that is about. Okay, so if I go ahead and draw a diagram of this, I want to draw two plates, right? We have two plates on Earth's crust. One is going to be moving this way. The other will move in the opposite direction. I'm going to make that a little bit bigger. Okay, and underneath we have new magma rising up to form new crust. Okay, but the important thing to know here is that we have two plates that are moving away from each other, opposite directions. The arrows are always pointing away from each other. So we can learn more about the plate boundaries by looking at ESRT page 5. Okay, so if you don't have your eCert out already, please take your eCert out now and open up to page 5. It should look something like this. This map here tells us all of the different locations of the types of plate boundaries that we can find on Earth. Okay, yesterday we looked at it very briefly and we looked at the different plate names. Okay, if you look, we have some of the names of major plates on Earth's surface. Here, for instance, we have the Eurasian plate. Over here, we have the North American plate. Down here, we have the Antarctic plate. Okay, those are the names of the plates. But if we look at where those plates meet, okay, where two plates come together, we can see the different type of relationships that exist here, the three different types of plate boundaries. So today we are learning about divergent plate boundaries. Let's look at the key on the bottom of the map that tells us what the different symbols mean. I'm looking for a divergent plate boundary. If I look at the key, that's the third symbol from the left, and it looks like this. Kind of like the diagram we drew, we have two arrows moving away from each other. Now that we know what the symbol looks like, let's go ahead and find all of the divergent plate boundaries on this map. I'm going to start here in the Atlantic Ocean. Okay, the mid-Atlantic ridge is a type of divergent plate boundary. Notice that I checked the symbol, okay? It has these two little lines next to each other, just like we see here, and the two arrows moving away from each other. Next to the symbol, it tells you the name of the ridge, the name of the boundary. This is the mid-Atlantic ridge. Let's go ahead and color that one in all the way. It goes all the way down the Atlantic Ocean. If you have a highlighter, please highlight the divergent plate boundaries in your own eCert as we go along. Okay, another major ridge, another major divergent plate boundary on this map is the East Pacific Ridge, right here. The East Pacific Ridge. Let's go ahead and color all of the East Pacific Ridge along the Pacific Plate. Okay, another ridge that we have is the Southeast Indian Ridge over here. Let's color in the Southeast Indian Ridge. We also have a little bit of the Southwest Indian Ridge next to it, and then the Mid-Indian Ridge. Okay, so one question that you could be asked is, you might see a question that asks, the East Pacific Ridge is a boundary between which two plates? Okay, remember these ridges that we just highlighted in yellow are where two plates meet. Okay, so for example, the East Pacific Ridge is right here. And the East Pacific Ridge is an area where two plates are moving away from each other. Which two plates are they? Well, if I look, okay, this plate here seems to be the Pacific plate. And the plate on the other side of the ridge seems to be the Antarctic plate. So the East Pacific Ridge is a boundary where the Pacific plate is moving in one direction and the Antarctic plate is moving in the opposite direction. How about the Southeast Indian Ridge? Let's look at that one over here in green. The Southeast Indian Ridge. We know it's a place where two plates are moving apart. Which two plates are moving away from each other in the Southeast Indian Ridge? Which two plates are moving away from each other in the Southeast Indian Ridge? Well, let's go ahead and see. On this side of the ridge, I seem to have the Indian-Australian plate. On the opposite side of the ridge, moving in the opposite direction, it looks like in bold text, I see this is the Antarctic plate. So the Southeast Indian Ridge is a divergent boundary where the Indian-Australian plate is moving in one direction and the Antarctic plate is moving in the other direction. Thanks so much for watching this one, guys. We'll see you again tomorrow. Have a great day.